Welcome everyone. I'm Tracy Fitzpatrick and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are thrilled to welcome you to today's event, Inside Google Cloud, Building Resilient Infrastructure. Presenting today's topic is Imran Ahmad. Imran is a seasoned technologist and AWS and Google Cloud authorized instructor, specializing in cloud computing, AI, and algorithm design. Known for simplifying complex concepts, he delivers hands-on, impactful training that empowers professionals to build secure, scalable cloud solutions. His writing and teaching bridge theory with real-world application, enhancing skills in cloud architecture, AI, ML, and DevOps. With a multi-cloud approach and a passion for innovation, Imran mentors learners through certifications and practical adoption strategies, making tech education clear, relevant, and career-focused. Please bear in mind that this is an overview of a very robust topic. We offer a collection of technical and business courses that can be tailored to your specific requirements. If you are interested in a further discussion, you can make an appointment with our learning consultants through our website at netcomlearning.com. Today's session is also being recorded, so you'll get free access to the recording in the next 24 hours via email. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adapting to change, and driving growth. We do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We do have 9 practice areas in which we specialize. They encompass people, process, and technology training. Today's presentation is from the Cloud Practice Area. Netcom Learning offers a comprehensive training portfolio of courses for the topic being covered today. Our upcoming classes include various trainings on the given courses. You can also access a variety of marketing assets, such as the free training and blogs, by clicking on the available event handout. These offerings can be found with a simple search on our website at netcomlearning.com. In this master class, IT and business leaders will learn practical strategies to design and manage resilient infrastructure using Google Cloud. With the growing demand for uninterrupted performance and secure operations, resilience is no longer optional, it's essential. Discover how to leverage Google Cloud's capabilities for high availability, disaster recovery, and scalable architecture, ensuring your systems remain secure, efficient, and ready for future growth. I would like to give you a quick overview of the logistics before we get started. To begin with, you do have the option to view in full screen by clicking on the full screen button on the right side of the GoToWebinar viewer. Simply hit the escape key to exit the full screen. Everyone has been muted except for our presenters. Feel free to submit any questions you have for the presenters here in the questions pane, and we will address them at the end of the session. And to get the best out of today's events, we've included the slides, courses we talk about, and marketing assets in the handout section of your GoToWebinar viewer. You may refer to them at any time to get a better understanding of today's topic. And we do realize that some of you may have to leave early and want to let you know that as you do leave the session today, you will be presented with a short survey. We would like to request for you to take a quick moment to participate in that survey. Your feedback really helps us understand your learning experience and improve our future sessions for you. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. And now I'd like to pass this over to our trainer to present today's topic. Hey, Imran, thank you so much for joining us today.
Okay, welcome everyone to this very interesting and important topic, and that is about building resilient infrastructure. And we'll also talk about that what is the relevance of building resilient infrastructure in 2025? What's the importance of it? And we will discuss everything within the context of Google Cloud in particular and cloud in general. That what is the importance of paying attention to this non-functional requirement? Resilience, building resilient infrastructure, that is a non-functional requirement, but we have to bake that in within the architecture while we are thinking about when we are designing our systems. Otherwise, at the end of the day, when we will bring the model to productions, the expectations will not be met. So let's look into the agenda. So we will start with talking about that why scalability and resilience that matters in 2025. So 2025 is the year when we have Gen AI driven use cases, AI driven use cases, opportunities to bring AI into productions, all of those things into production. So this is something where we are living in different times these days, and this is where scalability and resilience that becomes even more important. And if we think it through, it also there's also a question that are we talking about dev environment or are we talking about prod environment? Dev and prod, and in machine learning we call it as ML and ops. So are the requirements and the importance is the same in dev and prod, or is there something different there? We'll talk about this. So we look into the Google Cloud architecture. So this is not a webinar. In a short webinar, you cannot cover the whole thing, but what we will do is that we will talk about the relevant bits and pieces of Google Cloud in the context of scalability and resilience. And now, as these systems become more and more complex, so the way forward is to talk about best practices, design patterns, proven technologies that we know that work. And it's also about talking about scalability at every layer. The different layers, any sophisticated, any complex architecture, cloud, cluster computing, they are multi-tier, they are layered architectures, they are layers of abstraction, and those layers talk to each other. And what we need to do is that we need to think in terms of those layered architecture or multi-tier system and look at the system in totality and as well as component wise. So these non-functional requirements of scalability, resilience, they are applicable at the aggregated architecture as well as individual components. Together, they create a powerful, dependable architecture that is able to meet the needs of 2025, the ever demanding, ever increasing computing needs of 2025. And we'll also talk about the security and compliance. This is also a big non-functional requirements when we talk about these systems. Now, we said that why scalability and resilience matter in 2025. We will start with this. Now, I briefly talked about is that this is the year where the digital landscape has changed. There are some disruptive technologies that have taken over. That has taken over the technical world and as well as governments and our workflows, the way we used to think and the way we used to work. Now you will see here that that is driven by a couple of underlying phenomenon that make that happen. So first of all, if you look into these intelligent systems, they're all data driven. the evidence of a physical phenomenon that is captured by our data set. And the more data we can bring to the picture, the more intelligence we can extract from that, because actually this is all about formulating, understanding, and using the causal relationship, cause and effect relationship between features and labels among the underlying patterns. So it means that this is all data driven. So the first thing that we can note here is that there is explosion of data. So it's even difficult to think about it, but over 180 zettabytes of data. And if you don't know how many zeros it brings to the table, Google that in and you will be amazed. Now, it's such a huge, gigantic amount of data, but it needs to be created, consumed, and stored. Now, for that, we need systems that can actually cater for those needs, and these are ever increasing needs. If you listen to the talks these days, conferences, AI conferences, if you listen to what Elon Musk has to say, for example, or Sam Altman has to say, or you talk about Microsoft CEO Satya has to say. So all of those things, they agree on one point, and that is that we have to find new ways to store data, and we have to find new ways to build new computing capacity, and we have to find ways to bring energy to it all. These are all energy hungry architectures. So we have to basically somehow do that. And I was listening to Sam Altman, it was a very recent talk, and what he was saying was that at some point we have to think about sending, but this is what he was saying, that GPUs to space. I don't fully agree to that, but it's a far-fetched thought, at least in 2025. But the truth of the matter today is that the needs are expected to be huge, and we need to. So these are all vendors' headaches, that how to provision those resources. But as the users of those systems, someone is building the car and someone is just driving it. We are more like driving the car. But from the architecture point of view, first of all, we need to be aware that this is quite an explosion that is happening. And on the other side as well, the awareness will first of all bring more focus of our thought, and so that we can think about it, that how to build resilient and performant architectures. Then again, the landscape of 2025 is that AI ML is everywhere. It's integral to all modern applications. And we are also looking into workforce that is hybrid. It means that now, why hybrid workforce even matter here? It matters because with hybrid workforce comes because the network becomes single point of failure. Let's assume that you have infrastructure in your office, or you are depending on the cloud, and for some reason the uplink is down, and the cloud has it's a hybrid deployment, so there is some proprietary data that is linked to the cloud, and for some reason the link is down. It means that if you have a workforce of 30, 40, 100, 200, they are doing nothing for those 2 hours, and if you sum the salaries and everything up, and also the time of that, the most important thing is not always dollars. So it means that in order to build those efficient workforces, we have to create resilient architectures. And with the so what this brings to the picture is that these remote and hybrid work, they create more point of failures, more potential point of failures. If everyone is working from the laptop, and you are connected to the Wi-Fi, the workforce is connected to the Wi-Fi, there are a couple of point of failures, and if and you can build resiliency around the point of failures. But if as your architecture becomes more and more sophisticated, the point of failures also increase. We talked about the layered architecture. The interaction with each layer is, if the interaction between those layers is disrupted, that can bring the system down. So there are more point of failures. As we increase tiers, if your backend database is down, it means that you cannot communicate, so the system is down. Although everything is working, it is only the link between the middle tier and the back end. That's the only thing that is that has a glitch. But if the data is not there, what you are going to do with that? There is no state that is being stored. So your persistence is not there in long term and in short term. What's the implication of that is that you cannot use the system. And now the customer expectation is that customer is always looking for always on, something that is always working. Customer has become used to that expectation where it's looking for instance responsiveness. Customer is the end user. Customer is wants that you have offered something as a service. Customer does not need to know the sophistication and the point of failures and the guardrails around that. It just needs the service. You promise that it will. It's a bank manager who wants to determine that this applicant is high risk or not. So for that, it just want to push the button and get the answer. It doesn't bother about that how it's done. It needs the service that is always on, that is responsive, and there is a zero tolerance for lag or failure. At least that's the expectation. Now, let's look into the scalability and resilience, why it matters in 2025. Let's continue with that. I talked about the cost of downtime, especially when you have the remote or hybrid workforce, and downtime directly relates to the dollar that is lost and the time of the team that is lost. So this is something that you can directly measure, that how much time and dollars has been lost. Now, the thing is that there are, you can look at this this loss in 4 different dimensions. Number 1, financial. So financial means that every minute of downtime, it costs thousands. The second thing is that if you have offered the solution as a service, so it means that it has a reputational erosion. Trust is eroded. Customer can churn if it happens quite often. Then the third thing is that there are dependencies, there are supply chains, there are workflows. It's not that in a larger company, one process does not work in silo. It's a part of a larger workflow. And if you are disrupting that process, or the failure is disrupting that process, you are not, of course, you are on the other side of the aisle. You are trying to make it work. If the failure is disrupting the process, so what will happen is that the whole workflow, it will be disrupted. And those internal disruptions have a potential to bring business to a complete halt. And that's not good, of course. You can imagine the implications, And now there also can be data risk. Now, when we talk about the failures, we also look at that from 2 angles. First angle is that let's assume there was a 10 minutes failure or a 1 hour failure. Now, how much data was two metrics. Number one, how much data was lost when we restored the system. So usually what we have is that we have some stable snapshots, and we need to revert back to a stable snapshot. So if we are doing it, so how much data is lost, or is there any data that is lost? So if you think it through, it will depend that how often you are creating a snapshot. It's subjective. If you're creating a snapshot after 5 minutes, then in the worst case, 5 minutes of the data will be lost. It's not too hard to imagine that if this is the timeline, and in this timeline, what we have is that, of course, it's a timeline, so it's a time is increasing here. So what we're doing here is that after every 5 minutes, what we do is that we just take a snapshot. So and let's assume that something goes wrong here. So we'll revert back to this one. And now you can see that this is the data. Whatever changed this one, we have lost. Unless we are lucky that disruption happened right at the snapshot. Now you can calculate the probability, but the worst case you will have if your snapshot frequency is 5 minutes. So you can see that. So this is one thing that is there. One matrix that how in the worst case, how much data you can lose. The second thing is that in the worst case, how much time will you take to bring the system back? So for compliance reasons, you need to specify these two numbers. How much time it will take to bring the system back. Now, why it can change and how it can affect. So in Google Cloud, there is cold storage, for example, where you can store the data. You can so backups. You can always store that in archive, or you can put that in cloud storage. But it will cost more. But if you place that in archive, then retrieving the data will take some time. Right? And perhaps you want to store it. So this is something that you have to see, that it's a trade-off between cost and the time to recover. Now, I recover from the failure. And the key takeaways are that again, two non-functional requirements that are the focus for today. First one is scalability, and the second one is resilience. Scalability is again, it has different flavors. If you are talking in terms of prod and dev, two different types of environments, prod and dev. But in 2025, the news is that both are non-negotiable. Your customer want both of them. They want the system to be scalable. They want the system to be resilient, so that the critical workloads, now driven by AI, driven by this emerging new solutions, they can be deployed and used. Now, if you look into the real world examples, these days you look into 2025, we talked about 2025. 2025 brings with it one more aspect as well. And that aspect is about focusing on verticals. Our solutions used to be generic. Now we are looking in terms of verticals, that machine learning, but machine learning, not only machine learning is not good enough. machine learning in healthcare, machine learning in financial, machine learning in government, machine learning in social media. And with that comes specialization, the ability to specialize and customize. And that matters a lot these days. Now, if you look into the um, now here we are looking into three verticals that when we talk about scalability, e-commerce, streaming, and general AI ML workloads. Now with e-commerce, for example, if you talk about scalability, so now e-commerce patrons are always, it has high seasonality. So if you look into, for example, there is seasonality by the day or day of the week or month of the year. These are three different levels. Let's look into the first one. Time of the day means that from 9 to 5, demand will be more, perhaps. Then let's talk about day of the week. Demand will be more, perhaps for certain e-commerce websites during if it's an office supply, staples, for example, here in Canada. So it will be more between during the weekdays. So it means that, so this is the scalability there based on day of the week. And then if you look into month of the year, so during the holiday season, in the Christmas season, close to that, we are expected to have more traffic. Towards the end of the year, you will see that the demand increases as well. Now, so we have to first understand that, and based on that, what we need to do is that we need to design our solutions, and that will be our first aspect to that. But that is not all. We also need to understand that with this comes other use cases as well. And one of the other use cases that is there is about streaming. Now, streaming is it has certain characteristics that make it quite interesting. And the first of all, your customers, they cannot tolerate any disruption if they're watching a movie, if they're watching something. So they will like you to give them resilience. Just think about this, that if you're watching your favorite movie and all of a sudden system is down, you can tolerate it for once, you can tolerate it for a couple of times, but then you will basically complain about it. And if it happens too often, then what will happen is that you may even think to move to a different company. That can happen. So it means that for certain use cases, that is always like make or break. And the third one is general AI ML cases. Now, I mentioned this because what's there is that these days, large language models are also offered as a service. And this is where, so for example, if you look into what OpenAI platform offers you, they offer their AI ML platform as a service, as we call. And if you start now, let's say that your company start using that or start depending on that. So what's going to happen there is that you will want that to be resilient, performant, and elastic. And all of these, what together forms the bulk of non-functional requirements. One more to go with the requirements, and that one is security. Everything should be under the secure umbrella that you know that the data is protected. And so this is all focus on non-functional requirements, because in older days the focus was the talk was all about the functional requirements that directly were derived from the requirement documents. Now, when we are non-business users, non-technical users, non-technical users, the executives, decision makers, sometimes they do not think it through about the non-function requirements, and sometimes they do not fully understand the importance of that as well. And that is why it's important for us to specify that what are our expectations from the system that we are creating. Now, the resilience goals, this is a goal that is very hard to achieve. I would say that it's almost impossible to achieve, in fact, Now, this is the zero downtime during the failures. This is one goal. The second one is it needs to be cost effective. And the third one is that I talked about our we need to come up with two numbers, that how much data we can lose in the worst scenario. This is the first number. The second number is that if things go wrong, unfortunately, there is non-zero probability that failure will happen. This is another topic that I want to here just to indicate that for these modern systems, failure should be an expected event. This should not be a surprise. And if we treat the failure as an expected event, then we are not in a firefighting mode. So if the lifetime of our system is, let's say, 2 years, 3 years, 4 years, for 4 years that solution was deployed and implemented, we do not like to be in firefighting mode. Firefighting mode is that we were not expecting failure, it happened, and we are now trying to put off the fire. We should not be at that place. Failure is expected. As we increase the complexity of the system, more and more failures will happen, but by providing redundancy, we can still approach the zero downtime right here. Now, let's take a look at Google Cloud Platform. Some of you may be already using it, and I expect that for this diverse audience, you will have different exposure or different expertise level as far as Google Cloud is concerned. But let me start from the beginning. Now, Google Cloud Platform, GCP, it gives you a platform for cloud computing. It gives you a platform to create your solution. It gives you a platform to provision, compute, and data dimension, and make your architecture level choices and decisions. It's up to you it's like someone gives you 100 computers, 100 nodes, and they are very reliable, top-notch computers, and they are given to you, one of the best that are available. It's up to you how you use them. If you use it properly, if you connect them properly, if you understand their strengths and weaknesses, if you understand that what can be a potential point of failures, you can use it to its full potential. And if you do not fully understand that, even those top-notch systems that can create a system that is not resilient, that is not dependable, and that is not even fast. So this is what it brings to the picture. It's a platform. It's not a solution. It's a platform for you to create your solution. So it means that your subjective choices, your subjective architectural choices that you will make, that will bring resilience, that will bring with it scalability and the security that will make it a top-notch architecture. Now, at the back end, it's fully managed cloud platform. And now Google is one of those companies that actually uses all of the components that are provided in GCP. There is no exception. whatever is in GCP, whatever if you go to Google Cloud, so whatever is provided there, that is what Google actually uses. And now, if you have, so this is the platform we are talking about, Google Cloud Platform. And now in this platform, it's up to you how you dream and envision and implement your architecture and come up with these modern solutions that are resilient, that are reliable, that are performant, and that are secure. In order to get there, so if you want to navigate, if you want to see that what of the assets are available, you can click here on top left hand side. Let's look into that how we actually create this. Now, in order to navigate, what we can do here is that on top left hand side, we have this what we call it as the bookshelf. Now, this one is the bookshelf, right? We call it as bookshelf. And this bookshelf you will see in Google Cloud at different places. This is actually, it expands. This is one of the ways that we think it's an efficient to provide users ability to look at details. So click here, it will expand and it will show up. Now, what are these? These are different topics under which the services are offered. What is the example? And some of them, not all of them, some of them have this arrow in front of them. It means that it is expected to expand into a menu that will actually show those components. And for others, it's right there. So let's look into this, that how we can see that if you click here, so it shows you that these are the different services that are there. For cloud storage, there are buckets, they are monitoring, billing, so you can look into this. So this is the one way you can look at this. If you exactly know the name of the component or the asset, you can just write here. For example, you want to go to cloud storage. And if you click here, Google Cloud Storage, it will directly take you to Google Cloud Storage. So two ways of navigating is like you are in a library. If you know the name of the book, you can just go there and grab it. Otherwise, you will have to go to a shelf, a book about tourism, and the title says this is a shelf about tourism books, and from there you will find a book that is good for you. If you want to go by a topic, this is the way you will go. These are the titles of the shelves, and these are the books in a way, or you can directly write the name of the book and it will take you there. Now, going back to this, it means that Google Cloud Platform, it's a fully managed platform, not a solution. You will create the solution. It's not a solution, Based on the requirements, you will create the solution. And now, if you look into this, it comprises of compute, two dimensions as I call. It comprises of number one, that is compute. Number two, that is storage, data and storage. And networking is what keeps everything together. So this compute and storage, if they are built in different systems, what's there is that they are actually so now the thing is that any of these things can be down, right? So and we have to build resilience around that. Right? Now, if you look into this, resilience depends on inherent or provided redundancy. there is inherent redundancy. So for example, Google makes sure that the networking that is provided, networking that keeps everything together is not your responsibility. In fact, you cannot do much about it, right? That is something that is internal. You can just use it, So that is internal. Now there is and now there is, if you are providing the virtual machines or if you are using virtual machines, then it's up in your hands that how you provide these resilience there. Now, if you look into the uh, now, yeah, so it depends on your choices. It depends on your architecture choices that uh, that what type of system you use. For example, compute, storage, network, and the needs will be different depending on your choices. As I mentioned that if you used managed components, then resilience is built in. And but if you use components like infrastructure as a service, where you are choosing you are renting infrastructure, you're renting a computer, then it's your responsibility, So you have to first think about this, that whether resilience is if you are within Google Cloud, you can use platform as a service, like you can use Vertex AI, you can use BigQuery. Now, if you use BigQuery, then resilience is not your responsibility. Now, BigQuery, if you go back to Google Cloud, one of the most popular component of Google Cloud is BigQuery. What is BigQuery? BigQuery is Google thought of a tool that anyone can use anywhere without any learning curve. So it's a big demand. Think about it. So Google vision was that can we eventually create a tool that anyone can use anywhere without learning curve, and that person should have the complete power of Google Cloud Platform. That was the goal. We always that's a goal, but it's not that we 100% achieved that goal, but we came close to it. So BigQuery is a tool where all you need to do is that you just write SQL language. And you can say that anyone can write SQL language, right? So we know, anyone at least in this field knows SQL. So this is where the first requirement is met. The second requirement that we said anyone can use anywhere, it is you don't need to install it. You just authenticate, authorized, and navigate to BigQuery by using the bookshelf or the search. And once you are there, uh, all you need is a browser. So all you need is a browser. So it's not like Netezza, it's not like other large-scale tools that you have to sometimes spend days, weeks to install it and get it right. Open your browser and it's there. The full power of Google Cloud is at your fingertips. And the backend, you are not aware whether it's running on what type of hardware is being used, how much memory is being used, whether it's GPU memory, whether it's what is the hardware specification of that memory. None of this is applicable to the work that you are doing. It is again, I say that 50% of Google Cloud is BigQuery. It's my own. When I'm teaching for Google for the last 8 years, I always say that there are so many companies across the globe: Uber, Walmart, Boeing, and so many others. Spotify, I've taught there many times, and they are using Google Cloud due to BigQuery, because no other cloud platform provides a tool that is comparable. Yes, AWS has Redshift, but it's a different animal. Now, if you look into this, or what we have is that this BigQuery that we have, it's a very powerful tool. Now, it's a managed service because we thought of a tool that anyone can use anywhere without any without anyone can use anywhere without installing anything. It means that the hardware is managed by the vendor, that is Google. So with this promise, you don't have to look at resilience. Resilience and scalability, that becomes a managed service for you. You don't have to, if 50% of the Google Cloud is BigQuery, again, don't quote me on that, it's my own personal thought, then 50% of Google Cloud, you don't need to think about resilience. You don't have to think about scalability. So this is it's a managed service. So, and the other managed tools, because they will totally this is Google Cloud is one of the most elastic system that I have used. I regularly use Azure. I regularly use AWS. I'm instructor for AWS as well. I'm instructor for Google Cloud. At work, we use Azure. I'm heavily, I'm a heavy user. It's not that of all these three, but BigQuery is very elastic. It means that if you are working on your personal, let's say that tax season is just over, and you are working on your financial finances, you can use BigQuery. There's a free tier for it. You don't even have to pay for it if you qualify for that usage, and 99% chances are that for your personal finances you will be. It means that you're using, just like Google Docs, you're using Google Sheets, you are using BigQuery without paying anything. And at the same time, if you're working for federal government, and now you are dealing with the whole population, you want to calculate the risk factors, people getting diabetes, for example. You are working in Health Canada, now all of a sudden you have it's 40 million. Population of Canada is now more than 40 million. Now 40 million population is there on your data sets. It's not only for 40 million. You have the past data as well, and data from other countries as well. So now from your financial finance, you are still in the same session, and you move to the second data set, and you press run, and all of a sudden you are from 2 slots, it can expand to even 10,000, 20,000 slots. In how much time? Within a second. You won't even notice it. Now, elasticity, the ability to expand and shrink, either using predictive elasticity or eventual elasticity. Elasticity is the primary vehicle of providing cost-effective and performant architectures. So providing, because let's ignore cloud, and let's ignore that we are technical people. Just think about this. If you are just go to market and think about something that is performant. So let's focus on cars, because the performance is relevant to the cars. If you buy something that is performant in terms of car, it means that is fast. If you buy a Ferrari, it will be expensive, right? And if you buy a Vespa, it will be cheap, but it won't be performant, right? So it means that our intuition, our common sense says that performance systems cannot be cost effective. Now we move to the cloud, and we are looking at a requirement. We want to design systems that are both performant and they are cost effective as well. We are trying to bring the best of two worlds at the same spot. How to make that happen? Elasticity is our primary vehicle that can build systems that are performant and cost effective. Elasticity means that they can expand and shrink, just like the example I told you about your from your jump from your financial personal expenses to analyzing, predicting, and using the data about diabetes in the broader Canadian population. Now, for that, you need more resources, right? And let's assume that you worked on that on a couple of hours, and then you move back to your personal finances. Now the system will shrink. So you only have to pay for the time you were using the demanding use case, right? Not on so machine learning use cases. They have variability, variance in their demand and resource needs. So when you are training a large scale model, so for those couple of hours, you may need lots of resources. If they are not made available, either your timeline will expand to weeks or even months, or you have to simplify. You have to make simplistic assumptions that may just deface the whole problem, make it so much simplistic that it's no more useful to solve the problem, right? So elastic systems provide you that ability to, for those 2 hours, you have those 20,000 nodes that can work together to create a monster supercomputer at a fraction of the cost, perhaps at $20, $30, $50 that you can afford or the organization can afford. Right, but they cannot afford to run those 20,000 slots for the whole month 24/7. So elastic systems allow you to do that. Now, what I'm getting at here is that these non-functional requirements may be part of the component of the service that you're using, like BigQuery, or this is something that you have to design, and this is where it depends that what type of architecture choices you make. Now, I would like you to think about the use cases where you will use BigQuery and why BigQuery is not a silver bullet. Why, for some really important use cases, you will have to go towards virtual machines. And this is where this first part of it comes into the play, that for some use cases, you will have to use the virtual machine. This is one. The second thing is that the use cases may be legacy applications. They may or you may just need full control over the operating system. You want a certain version of the operating system due to some subtle details, certain libraries. I'll give you an example here. If my friend, he did PhD, he just completed PhD in at Carleton, recently. And towards the end of that, as it always happens, the last mile is the longest. PhD sometimes gets stuck towards the end, and it happens all the time. So at the end, he was getting frustrated, and his R code won't work. So I said that, can you? Can I help him, because he's such a good friend. He has helped me in so many ways. So I said that, can you send me the code? Just send me a Git repo through Git, and I will try. I will see that what's the problem. And he said that my code, my R code, it depends on a certain Fortran library. Fortran age, if it's used to be a language in 90s. So he said that one, it's a statistical package. You have to install that Fortran library in a certain way, and I'm sure you cannot do that. So I'll have to be at your place to install that Fortran library, and then you can install R, and then it will work. And he came to my place and he spent some time uh, fighting, struggling with installing that Fortran code. And once that is done, then I was able to run R. Now, the reason I'm mentioning that is that if now there is no replacement for that, or at least that very specialized piece of software that needed that Fortran library. Now, this is where you will always find places where BigQuery is not the answer. You need those custom libraries, custom solutions. And this is where you will bring virtual machines, where you are either dealing with the legacy applications, or you are using some custom configurations, or you want to make sure that there's a reason, or there is a software stack that is dependent on that operating system. So all of these cases where Compute Engine is still there, and for the foreseeable future, it will remain an important part of Google Cloud and other cloud solutions as well. And people like my friend, my friend could have installed that on Google Cloud. Now and just share the virtual machine with me. And in fact, if he could have customized a virtual machine, that is a template, that is a repeatable solution that he can share with his professor, share with me, share with other people as well. And he does not have to travel to my home to install that Fortran library. So this is where now, but with the Compute Engine, it means that now we are taking charge. We said, okay, we'll have our compute solutions, but now we are responsible for providing resilience. We are responsible for providing the elasticity as well. Going back to that example, let's say that my friend, the same person who was my friend who was stuck in running that R code. R is a language, by the way. It's a very popular language, especially for certain areas in AI and statistics. It's one of the oldest and most. It's a specialized language, not like Python that is general purpose. And the people who love R, they just love R. It's like it has a whole cult around it that those people want to use Python. So if now if this is the case where my friend has now created the solution that it really works on the cloud, on the virtual machines. Now, let's say that he has taken help from me and other people are trying to use that as well. Now he now needs to create first of all, he needs to create elastic solution that can expand and shrink so that two or three or five people who are trying to help him can use it. The second thing is that let's assume that my friend, he has now his PhD thesis, he is giving the demo, that is a pass or fail. External is there, external has traveled all the way from Greece to be part of the defense. And this is the grand finale of the effort of 5 years. And in that 2 hours, the destiny will be decided. Now, my friend cannot afford to system to be down. He cannot afford that, just in case if the machine does not work. So it needs to be resilient. The external will travel back to Greece. There is an external supervisor. He traveled all the way from Greece and she needs to go back. And it's not that if the system is down, it will be a disaster, Now it means that the way we can think about this is that perhaps there may be two virtual machines, one on that is running, one on the standby. Then what about the data? This is that person's PhD thesis for the last 5 years. Lots of data is there. So if he's using SQL database, that need to be resilient as well. What if the compute is working, but while all this stress that person is giving the demo and the database is down. Look at, just imagine the disaster it can bring to the table. So it means that we need resilience, that thesis or that defense will be over in a couple of hours. But for the companies, when they are providing these solutions, they need to be resilient and they need to be dependable. So this is where if you are going towards the path of using managed components like BigQuery, then this is not your headache. Google will do that for you. But if I mentioned there will be all sorts of situations where BigQuery or tools like BigQuery is not the answer, then you'll have to use Compute Engine or tools like Compute Engine. You have to use SQL database in Google Cloud or Cloud SQL, or you have to provide the resilience yourself. You have to one in the main, one to be in the standby. You have to think it through. What are the implications of that in the dev time and in the prod time? Let's go back to the example of my friend who is looking for me to complete his PhD. He's frustrated. 5 years has gone. He needs to start working. It's almost too much time. Now he's taking help from me. But there are two parts of the equation: dev time and production time. In that example, dev time is that when I am trying to help him, or he's working to evolve a solution. If the system is down, we can live with that, So if the system is down, if the system is not working, I can say, okay, I'll drink a cup of coffee, I'll come back and hopefully it will be back, In dev time, when we are developing solutions, downtime has consequences. Of course, if these are your workforce, I mentioned that there are 4 different ways it will affect the workforce. But in production, if that person is essentially giving the presentation and those 15 minutes is all he has to prove that his algorithm actually works, now downtime there is not acceptable. So it means that you will, based on the use case, you will have different degree of urgency to provide solution to cater for the downtime in dev and prod. So that's why you have to first see the needs and the implications before you do that. Now, there's other solution as well in Google Cloud, that is Kubernetes. Kubernetes is an orchestrator. It's an orchestrator for Docker containers. And if you're using Dockerized solutions, then what you can do in Dockerized solution is that you can bring it's a simpler problem to solve, that you can have redundant Docker containers, and and Kubernetes essentially manage redundancy for you. Kubernetes system provides you the ability to specify your need for elasticity and resilience, and it will manage that for you. It has that intelligence. So there are 3 different levels. If you're using managed services, everything taken care of by the vendor, that is Google in this case, and you just relax and pay attention to the functional requirements. Non-functional requirements are almost taken care of. Security is something that you have to decide a bit. If you are using the other extreme is when you are using VMs, virtual machines, then it's no more different than using your buying machines from Best Buy and using that at your home. And now in the middle, somewhere in the middle is the Dockerized solutions, where you use GKE, Kubernetes engine. And this is where those Docker containers that you have, those they becomes self-contained functional solutions, and if one of them goes down, yeah, the other ones just needs to uh, be taken to the active state, and the service is operational. You know, and Kubernetes has the intelligence to fully manage that for you, and that what it means is that Kubernetes-based systems, whenever you choose to do that, because of its sophisticated Docker management, it is able to provide resilience, it is able to provide security, it is able to provide performance out of the box. Now, if you look into the core infrastructure service, so this is what I said is that in Google Cloud, if it depends on the applications. Applications can be event driven. What is an event driven application? Event driven application is that someone has submitted the tax returns that needs to be processed. What is the event? Event is the submission of tax returns, and they need to be processed, right? And based on that, there will be need for auto scaling, there will be need for traffic splitting, and all of these requirements, it goes with the requirements of event-driven workloads. Now, it can be serverless containers. Now, Kubernetes, this one, it it is great, but it needs some babysitting as well. So you have to make some choices that how big the cluster would be. What is how many pods? Dockers are sort of basically they exist as pods in Kubernetes. You have to choose the size of the cluster. You have to choose also there are some choices that you have to make. This is not push button fully managed like BigQuery. If you want to have BigQuery like management where everything is taken care of, you do not need to worry about the hardware, then this is the Cloud Run. Cloud Run is for containers what BigQuery is for data warehousing applications. It's a push button solution. It takes away from you how to babysit and how to implement the non-functional requirements in your infrastructure. And if you look into the other use cases as well. So I think it's time for a break. Let's take a short break and then we will come back. Okay, enjoy your break.
Sure, we are now going to take a 5-minute break, but before we do that, we are going to launch a quick poll that we want to invite you to participate in. Doing so helps us know how we can better serve you by telling us who might be interested in more information or in taking some additional training. In addition, we have a lot more informative webinars coming up, so please go to netcomlearning.com/webinars in order to register.
Welcome back, everyone. Let's continue from where we left off.
So now database is an example. Now database is so first of all, if something is lost in let's think about an example here. So if you are, let's say that you are working on your laptop and you are editing your, let's go back to the same example that my same friend who is struggling with, who was struggling. Now his good news is that his thesis is passed and he is now a PhD doctor. That's the good news. And towards the end of that, as it usually happens, he was facing a rough time. To last mile is the longest, as we always say. Now, let's say that he was working on his thesis that he has written in the last 2-3 years. Now he is just trying to give some final touches there, and his Microsoft Word, it just crashed. Microsoft just crashed, and he said, "Oh my God, it's a bad day." But the data is there. The file is securely saved. The backup copy is automatically created. It's only a matter of restarting Microsoft Word. Everything will be there. The failure is in the compute dimension. In this case, the compute dimension is the Microsoft Word, that is the word processing software. He can relax. He just wasted. He just need to restart it. On the other hand, if something happened on the data dimension, your Microsoft Word is still working, but on the software where it stored, it just crashed, and the hard disk it stored crashed, and there is no backup. Now you imagine, and all of a sudden Microsoft Word showed that there is an error at the back end because he has mounted an external drive, and that drive failed, and there is no backup. Now just think about the implications, right? So it means that the failure in data dimension is almost always more severe. It has more severe consequences. We have to protect data dimension. Compute dimension, it's a glitch, but data dimension is a disaster. There's a difference between a glitch and the disaster. It's the magnitude of impact that the failure in both these dimensions bring to the picture. So, and there are different cloud design patterns. This is not a webinar for going through that, but one of the popular and the simplest one to understand is it's a bifurcation, separation between data and compute dimension. Data and computation should be stored separate from each other, and they should be designed in a way that they can expand and shrink independent of each other. And if you turn the compute dimension down, the data should be there. Just like, again, going back to the example of my friend struggling with completing his PhD, towards the end of that, now it's done, and it's but the data dimension, the thesis that he has stored on his disk, this is fair for the last 5 years. It is evolving, but the data is there. The compute dimension is the Microsoft Word that he can just shut it down, but the data will be there. And if we bring the same concept to the compute, this is one of the second biggest way that we can create infrastructure that are performant and cost effective. They are performant and cost effective. Ferrari at the cost of Vespa, not the other way around. And the way we do that is that we can create architectures with separation between data and compute dimension. It means that compute becomes need-based. You can shut it down. You can shut down the cluster when you don't need it. And in data dimension, where you want to make sure that now going back to now, this is the way you are going to design, envision, and aim for this level of resilience and elasticity, and making performant and cost-effective architectures. But if you're using Cloud SQL, Cloud SQL is again infrastructure as a service. I mentioned that maybe you are using some functions, SQL functions that are very much dependent on that database, and you cannot use BigQuery. Again, I walked you through that there will be all sorts of use cases where you have to use, you are dependent on the hardware or the lower levels operating system calls, or there's a reason that there's a dependency at the lower levels, and you have to move towards infrastructure as a service, and that takes you to Cloud SQL in Google Cloud. Now, if you are going to that level, then you become responsible for managing the resilience. And the way you can do that is by making sure that you have high availability available. And you have to think it through that I said that you have to give a number or think about a number that how far you can recover. So now you need to enable the read replicas, and all of them, or you also for certain use cases, you need, if it's a global application, global service that you're providing, then you have to think that how you are going to build resilience across different regions. And it means that if your solution exists across different regions, then at the back end, you need support from the vendor, cloud in this case. It can provide you with that service that can be offered across the globe. Now, and you will be looking for architectures that can implement automatic failover with minimum time to move to the redundant system. Now, if you look into the backbone, so Google infrastructure, Google is a truly global platform. For Google, it's not an afterthought to make it global because its business is global. Before offering Google Cloud as a service, Google Business was one of the it was the most complex and sophisticated architecture that was global in nature. That provided the search capabilities, it provided Gmail and the things from India to Nigeria, from Alaska to Japan. People can expect almost the same quality of service, right? The same functionality using its traditional services, right? YouTube included. Now, the thing here is that Google has used its expertise, its strength in managing and providing solutions for its global architecture to the as a platform, and that becomes GCP. And in that GCP, there are 40 different regions spread across the globe. It spans our blue planet. And within that, there are so zones are each of this region. There are 2 or 3 different data centers, if you can call that. So there is regions, and within regions, we have redundant data centers. Data center is a simplistic name because zone also has a compute dimension, but they have those zones within those regions that provide the necessary resilience. And now, if you look into this, there are 6 different pillars on which this architecture stands. So these are the well-designed, well-architected plan principles. What are those 6 principles? So first of them is about the system design. System design means that when you're designing these systems, you have to think in terms of totality. It's not that you can focus on only one component and move on. So you have to see that this component exists part of a larger workflow. So you do not design a system or a component or part of architecture in isolation, because that is part of a larger solution, and without contextualizing it in the right way, your architecture will be pedestrian in nature. It cannot solve quite complex problems. Now, the second thing is about the operational excellence. And the operational excellence, what it means is that operational excellence means that when you're designing these systems, you look at the long term. You build reusable solution. You use YAML files, unique configuration files. You use orchestrators. You create repeatable templates. Operational excellence means that you do not provide shortcuts, but you provide solutions that you can parameterize, change, tune in the future. So operational excellence is the second thing. The third thing is the security, privacy, and compliance. Whatever you do, it's a vertical. It means that it will apply to all the layers within your system. And whatever solution you are creating, first of all, you need to discover the compliance level, and then you need to make sure that it conforms to the applicable level as well. And then it's about reliability. Reliability means that it's a system. Reliability is a vague word than resilience. Reliability means that your system as a whole that has the trust of the end user. And resilience is one of the perhaps the most important component of it. But reliable means that it's a reliable, just like a person. It's a reliable person. It's a reliable service. Now, what brings the reliability to the mind of customer? Resilience will be a big part of it. Okay? Now, but reliability will also, if it depends on the service, it will also depend on the accuracy of that, the trust, the security. A person feels that to be a reliable solution on which it can rely and use that for some critical use case. Then comes the cost optimization. Who wants to pay extra? Everyone is trying to save money as individual, as community, as an organization, and cost optimization is always one of the biggest factors, one of the biggest limiting factors of using cloud. And as cloud systems, they go beyond from experimentation to actually being taken seriously and use part of critical infrastructure for years now. Now, finding opportunities to save cost is becoming more and more important as these systems become more expensive as well. Now, and then comes the performance. So these last two is where we are dreaming for what? Ferrari at the cost of Vespa. Both are Italian. Yeah. Now, if you look into let's look into that. What are the design for resilience? What are the best practices? What are the design patterns? First of all, whenever detect the point of failures, and based on that, you want to make sure that you avoid them, single point of failure. So it means that you provide redundancy, you provide multiple paths. If they are virtual machines, you provide more than virtual machines. If there's a need, if the business allows you to do that, then what you do is that you deploy that to multiple zones, but it will increase cost as well. So I have to think it through, see that whether this is something that is applicable or not, but that will definitely improve it. And now also use cloud load balancer for smart traffic routing, because load balancer, why they conform to these requirements, because load balancer think about your team, uh, at work. Let's say that you have a team of 5 people. Manager, your manager is always a load balancer, try to distribute load among his or her team. If you're a good load balancer, your manager is a good load balancer, then the team will be fully utilized. If your manager is not a good load balancer, what's going to happen is that one of the members of the team will watch Netflix, and with all the resilience that we have talked about, and other people, they will be they will feel themselves to be exploited. So load balancer in technical terms do the same with the resources that are available on the cloud, and it means that it makes sure that there are no hotspots that are being created. Then there are automatic recovery and decoupling, auto healing, for example. Auto healing is a difficult thing to achieve. It means that but we aim for it. Auto healing means that if things go wrong, can the system fully identify and rectify it, recover from failures automatically, right? Now, if you look into the best practices in the data dimension, the previous one was about the compute dimension. So it means that if it's a Google Cloud Storage, take backups. Don't make sure that they are taken at regular intervals. And snapshots, I talked about this, and then make sure that these numbers, how much time will it take to bring back systems, and how to do that. We should not be in firefighting mode. So this is what it says, that failure is expected. Failure is not a surprise. As our system becomes more and more sophisticated, as we increase the layers, as we increase the tiers in our systems, it becomes we are creating more point of failures with all its performance as well. Now, scalability at every layer, we talked about this. It means that we want to make sure that scalability is not, when we talk about aggregated scalability, the system scalability, actually that is implemented through providing scalability at each individual layers. And now you can talk about the compute engine auto scaling. Now, compute engine, cloud also offers that if you choose that, what are your scalability requirements? It can do that on, it can manage it, but you have to specify the policy. And usually you specify it by specifying 3 numbers. First one is the minimum. So you say that, OK, at minimum, I want 2 machines. I have a budget for paying maximum for 5 machines. And if the number is, if the load is normal, then I will go with 3 number. The first one is minimum, maximum, and then normal. So this is your policy, and these 3 numbers, directly or indirectly, they are indicated by your policy. And this is what now, if you look into the scalability at each layer in the storage, so Google Cloud itself, it has almost an infinite object storage. Of course, there are limits, but for us as a user, the data sets that we have, you can it helps to think that it has there's no limit on how much data that you can save. Don't take it as a challenge and don't try to break the system. Don't go overboard with that. Of course, there is nothing infinite here in the world. But for most use cases, this is what is true. And the big table is now you can use Bigtable for NoSQL and the Cloud Spanner. Both Bigtable and Spanner, they are managed services. It means that just like BigQuery, the resilience is a promise. It's the responsibility of the vendor, and you don't have to worry about that. Now, if you're talking about each layer, now Cloud SQL, the way now here, it's about the Google Cloud's responsibility to provide resilience, but that's not the case for with the Cloud SQL. Cloud SQL does it in a interesting way. So the way it covers that is that if this is your main Cloud SQL, it allows you to create a replica. And that is a read replica. So it means because if you talk about redundancy, providing redundancy in a write process, it's a difficult thing to implement. Because if two processes starts writing, changing the data, it can create race conditions, and that can affect the integrity of the whole process. But read is a different thing, you know. Read providing redundancy in the read is much simpler, and this is what we usually do. So read replica, it does not affect the write process, but for read it works pretty well. Now, this is where we call it as the shared responsibility model. And I talked about that in the beginning as well. So we need to think about this, that what is the responsibility of the user and what's the responsibility of the provider. And this is where we, for example, if we are using BigQuery, I mentioned that the hardware is the total responsibility of providing resiliency is the propriety of Google hardware, because it's not visible to the end user. So how can it can take any responsibility that is not even visible? If you are using Gmail, for example, Gmail, just to give you an example, you cannot take advantage, you cannot take responsibility of the security. Once you have written the email and you have pressed the send button, it's up to the Google that how it is securely delivered to the end user in a reliable and secure manner. So that is the responsibility of Google. If the network is not your responsibility to manage the network that links your Gmail to the end user, it's not your responsibility. You don't have any visibility. You know how you can manage something that is not visible to you. The same thing you have to do. You have to ask yourself that in Google Cloud, if something is not visible, then you don't have to manage it as well. But if you have to manage, then IAM service, you know, it provides you authentication or authorization services that you can log in, authenticate yourself, and or you can create roles. But when you're doing it, IAM, then it's a good practice that you follow the principle of least privilege. When you create these roles, when you have to do that, when you have to create logins, only give the permission that are bare minimum instead of going the other way around. Go with default roles. They are roles like there are certain roles, for example, people who will manage BigQuery, the people who will be the admin of a cluster of virtual machines, or so use those predefined roles and customize it or if needed. Also use service roles. It means that they are not tied to a user, we are tied to a service. Now, if you look into the network security, network security is again for certain use cases when you are when you're creating virtual machines, then you have to do the plumbing as well. And the plumbing is in this case is the network. Have to make sure that you are creating the firewall rules. You are protecting your system against denial of service attack. So there is an intelligent component in Google that is called Cloud Armor. It can predict and protect your system against attack. That is called Cloud Armor. So you can be aware of that and you can use it. And you make sure that you turn on the encryption and at rest and at transit, and you do not turn that off and use now if you want to look into the compliance, so again, it depends on the vertical and the region where you're living at. Different countries, Europe has different laws, and within Europe are different vertical. If you are working on a healthcare product in Europe, then it means that you are under different compliance level as compared to working in a social media company in Silicon Valley. So first of all, you have to look into that under which compliance your solution is. And based on that, you have to essentially come up with, first of all, see that what are the requirements. And based on that, you have to be aware of the checklist and make an effort that you conform to it. Now, data residency and sovereignty, because we're talking about compliance, your data will be under the rules where it resides. So let's assume I'm working for Canadian federal government and my data resides in US. I have created a bucket that is not local to Canada, but it is basically I've uploaded the data that is in US. So US laws will be applied to that data, and this is not what we want. We want Canadian laws to be applied to the Canadian data. And that is why when you are in Google Console, it's very easy to forget that actually whatever we are storing, the buckets, they are physically stored in different regions. If you upload the data to a bucket in Japan, so Japanese laws will apply there. And for certain use cases, this is important that data residency, you say, OK, this is the data that I have. And you discovered that there is a 20% discount if I store that data in Brazil. In fact, Brazil is one of the expensive regions all over the globe. Let's change the example. Let's say that in Australia, you said, OK, yes, there will be latency. Yes, it will be slow, but we can live with that because it's 20% discount. We don't need speed for it. But be aware that the Australian laws will be applicable on that data. And they may be different if Facebook or if Australia has made an accommodation to supply the data to US federal government, then that will be applicable to your data. Although you are in Canada, and in Canada that was not needed, you are working in federal government, and all of a sudden the data that should not be provided to US federal government, it needs without a process. It's not that without a process it should not be visible to them. So now all of a sudden, just by a click of a button, that is visible, and you may lose your job. So it means that it seems like a simplistic web page, but actually the data that you're moving that are large scale, the solutions that you're providing, they are on large scale, and we need to be aware of that. Now, then enforce, restrict, control, and mandate. This is the policy that the way you can provide this. Now, if you want to do the cost optimization, first thing is that you have to minimize your computing cost. Then you have to make sure that you are right sizing. Now, over designing is something that is as much as a problem as under designing. Sometimes we overthink, both in our lives and sometimes we overthink when we design as well. People when they buy home, they buy 5-bedroom home, although it's just a couple. They say, okay, this is so they over design. The same strategy when they apply that on cloud. So they forget about that. In the case of home, there is no elasticity perhaps, but in the cloud there's elasticity. It's very simple to change the virtual machines from 1 to 5. It's in fact, it's even simpler to provide elasticity when the system can decide it for you. So you don't have to over design. Design for the situation that you are currently in with providing the room for expansion. provision for expansion. Provide those means. Don't ignore that. Don't make it static. That dynamic expansion is allowed, expected, and this is something that will bring the cost down. Now, you can use, for example, there are spot machines. You can see that what are the implications of that. They are discounted at they are discounted by 90%. It means that instead of $100, you are paying just $10. But the implications of using these spot machines are that they are in fact machines that Google had rent them out with the promise that Google can take it back at any time. So it means that you can use it for certain use cases, but not for critical use cases. Then they are, preemptible instance. So there are different types of machines, and based on that, they can help you to optimize the cost. So and if you are looking for in the case of data, so lifecycle management, that don't store everything in the most expensive choice, that is the default bucket. If you're not using data for 90 days, then move that to Nearline. If you're not using for a whole year, it's just an archive, then 80% savings will be achieved by moving it to CoreLine. Now, if you look into performance optimization techniques, it's about matching your hardware, your architecture choice to the requirements. If it's a machine learning load, to choose GPUs, but GPUs will almost double the cost of your infrastructure. But if it brings the total cost down in terms of the time, then this is the way to go. And then you choose the right type of machines, you choose right type of the storage, use SSD, and those choices will bring the cost down and will help you buying Ferrari at the cost of Vespa. It means that it will make your whole solution cost effective and performant. And if you pay attention to the resilience, then it will make it reliable as well. Now, network performance is something that, first of all, it's at the back end, but you want to make sure that you are taking full advantage of that as well. It means that if your customers are in India, so choose the data center that is closer to India. Don't provide it a service from Ottawa, or Montreal. The data center is in the Montreal. So choose the region that is closer to that. Take full advantage of Google's global network that will reduce latency as well. Use connection pooling. It will now. If you want to look into the content delivery network, CDN is what makes YouTube work fast in places like Nigeria. Yeah, they are these days the quality of service of YouTube will almost be the same as in Silicon Valley, and the reason is that it's CDN. What is CDN? CDN caches. They are intelligent cache that are brought closer to the users, the high density users. Nigeria is one of the largest countries in the world, largest in Africa, and I think this is one of the largest in the world as well. So if you look into Nigeria, they are, first of all, very creative. In Hollywood movies, the back end, this is one of the most popular countries where the back end is rendered and created, and they are very, very creative. Yeah. So Hollywood is one, and they call it as Tollywood, I think, or Nollywood, something like that. And then there's Bollywood. So Bollywood and the one that are created in Nigeria, they create one of the largest amount of movies as well. So it means that for them, perhaps they are watching YouTube videos as well. So CDN is those intelligent caches that, focusing on Nigeria, there are usage patterns that will be provided closer to Nigeria, so that for those read only, they are not, they are just watching those movies, those multimedia files, they are brought closer to them, so they are fetched from Nigeria, and it's the vendor's responsibility to keep them fresh. and that backend is managed by. And so YouTube works on that, Facebook works on this principle, and in cloud, you have to do that. You have to be aware that this is available. This is called CDN. It means that if you have use cases like this, think about that, enable that, and it will increase the experience by many folds without increasing cost. Now, then we have yeah, database performance. I talked about the read replicas. Now, read replicas is one of the easiest way, but you can also think about Redis and memory stores if you want those high velocity intelligent cache systems as well. Now, key takeaways are that scalability and resilience, they are essential, especially with the emerging workloads, AI-based workloads that wants more demanding architectures, but the expectation from the customers are non-interrupted service, and customer in 2025 does not care about the backend. It needs cost-effective, resilient, performant, uninterrupted service, and it means that we need to make sure that we use those services. Now, this brings us towards the end of this important topic, because if we do not provide these non-functional, if we do not meet these non-functional requirements, no matter how accurately we implement the functional requirements, you are asked to create a fraud detection service, is working perfectly fine. But if the service is down, if the integrity is of the data is affected, if the security is not there, if it's not cost effective, or if it's not resilient, bank manager wants to use it, it's down, then it's not implemented. Customer will not be happy. That's why the resilient and secure systems, they are available. This is one of the key requirements in 2025 as we move more and more towards AI-driven use cases where machine learning is an important component of the end solution that we are creating, but it's also creating pressure on our backend architectures. We need to be aware of that and use these best practices and design patterns to come up with these solutions. So that's the end of my presentation, and now it's time for Q&A. Any questions that you might have?
Thank you, Imran. That was incredibly insightful. Now, I know everyone's looking forward to the Q&A session, so go ahead and start putting your questions into the questions panel. And while you do that, I'd like to give the presentation rights over to Ifla, our product marketing person, who's going to introduce you to some of our fantastic promotions and webinar-related courses.
Thank you, Tracy. Insightful session. I believe everyone must have learned something new today or would have been able to brush up their skills around Google Cloud technology.
So firstly, I'm excited to announce that Netcom Learning is now an authorized training partner for Google Cloud, making us your go-to destination for cloud skilling. With this milestone, we are proud to offer comprehensive training across the 3 leading cloud technologies globally: Microsoft Azure, AWS Cloud, and now Google Cloud. So Netcom Learning is your one-stop shop for cloud skilling. I would also quickly like to take you through some of our hand-picked resources, which we think will immensely help in accelerating your Google Cloud skilling journey. Well, this document here that I'm presenting has been shared with you all in the handout section of GoToWebinar panel. You can download this document and access all the resources and browse all the offerings we have curated for you. So first up is the list of our recommended courses, which we feel will best suit your learning journey after attending our masterclass. So all these courses here are hyperlinked. Feel free to go through them post-event and check out the course descriptions and prerequisites and the value it can add to you and your team skill sets. Additionally, we have curated a blend of resources, including our upcoming and on-demand events, as well as some informative and educational blogs. So you can make the most of these resources to gain extensive knowledge on the Google Cloud topics they cover. Also, here I would like to inform you that today's masterclass session is being recorded. So, in case you want to refer back to any of the topics that were covered by the trainer today, we'll be sharing the recording link with you through emails, and also you can access the link here on the handout so that you can revisit the session and learn at your own pace. Now, apart from our virtual sessions, you can also catch all the relevant updates related to IT and business training on our social media handles. So please feel free to follow us on LinkedIn, Twitter, and Instagram, and also subscribe to our YouTube channel for all the latest updates. Our official pages and channels are linked here on the icons. Finally, if you have any suggestions regarding the topics you would like us to cover in our upcoming webinars and masterclasses, please don't hesitate to send us a direct message or leave a comment on our social media posts, or you can just simply email us at google@netcomlearning.com. We would definitely try to come up with the sessions on your suggested topics. Thank you once again for joining us today. You guys have a good one. Thank you.
Thanks so much for guiding us through that information, Ifla. And now we're going to go ahead and jump right into our question and answer session. The first question is, what new challenges in 2025 make scalability and resilience more critical than before?
Okay, yeah, that's a good question. I briefly talked about this, but in 2025, I talk about the need for Gen AI, but now as Gen AI become parts of the workflow, of the production workflow in 2025, that was not the case last year. If companies want intelligent chatbots that use AI, now AI is it uses all of the requirements that we talked about. It needs sophisticated architectures. So now we have to go back to the drawing board, and we have to see that now how we can cater for. It brings more opportunities as well. It brings opportunity to create new designs. But in 2025, it becomes absolutely important that we meet these challenges. Otherwise, chatbot will be down. That intelligent Gen AI chatbot will be down most of the time, and company will just move on to something much simpler. So in 2025, it's no more a luxury; it's a necessity.
Second question, which core Google Cloud components are most important for building resilient systems?
Okay, so if you are using managed services, I mentioned that if you're managed services, then it's more like Google's responsibility. But if you are using, for example, virtual machines or Cloud SQL, then you have to pay attention to that how you're going to provide that. So one popular way is that you think about using a load balancer. And at the load balancer, it balances the load in in more than one virtual machines, but it can also act as an enabler for creating resilient system. And if one of the system is down, it will just try to balance it on other three machines. This is and the same goes for if you have, for example, Dockerized workloads. Then Kubernetes, managed Kubernetes, that's an important component of that. If you are using managed services, then it's totally taken care of. Then you don't have to think it through. But for infrastructure as a service, these are components that you have to pay attention.
Next question in the queue. What are the top strategies for minimizing downtime on Google Cloud?
Okay, so the strategy for downtime is that you build resilience. And what you do is that you try to think about a bare minimum that can meet the functional requirements. It means that things will be slow, because you are just providing the functional requirements, but system will not be down. It's not totally out. So think about that resilient bare minimum services that can provide the end-to-end architecture, even if some supporting services are down. So this is one of the ways that that's a design philosophy. First, think about this and making sure that that is bulletproof.
Another question? How can we ensure scalability from the network layer up to the application layer?
Okay, so um, now in the application layer, the scalability is so first of all, if I mention if the scalability is not across the board, it will create a bottleneck. And providing basically elasticity or scalability at one of the layers that will not essentially remove the bottleneck. So in the application layer, it's all about providing more computing resources. Think about this. So it goes in 2 or 3 different steps. First, you have to see that where is the bottleneck, right? Otherwise, we are just over designing. And uh, once you identify the bottleneck, if it's in the computing resources, then try to increase the size of that, provide provision more resources. And once you have done that, then you monitor that. You see that whether this is a persistent increase in demand or it has some seasonality component to it based on time of the day of the week or month of the year. And based on that, what you do is that you design elasticity policy so the cost remains down and the performance remains high.
And our final question is, how do we balance strong security with high availability in cloud design?
Yeah, so as you increase the amount of security, so sometimes you may think that you have to basically authenticate and authorize all the time, multi-factor authentication, keys are brought from somewhere, and that means sometimes that the system is not always available. Use service accounts, use token-based authentication authorization, and all of them will help that you don't have to actually create a process that you have to manually go through that and automate those processes in that way. Tokens and service accounts are and role-based access. These are ways where you can increase the security without increasing too much bureaucracy or red tape, and that will it means that you will have highly available but secure systems.
Once again, I want to remind you that as you leave this session today, you will be presented with a short survey. We would like to request for you to help us by taking a quick moment to participate in that survey. Your feedback really helps us understand your learning experience as we are constantly looking at how we can improve our future sessions. The survey answers are measured on a scale of 1 to 5, 5 representing outstanding and 1 representing poor. We want to thank all of you for joining us today, and if you do come up with any additional questions, feel free to send them to webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us soon. Feel free to tell your friends and colleagues about our webinars and other courses. Have a great day, everyone.